All right, so we're going to talk about how to find the equation of a polynomial given some information like the roots. And so the example here is we're going to try and write an equation of a polynomial with degree 3. And I'm telling you that the roots are, two of the roots are 2 and 3 minus 4i. And I also know that f of 1 equals negative 10. So when I plug in 1, I get negative 10. The first thing you'll notice is that I only have 2 roots. Degree 3, I'm supposed to have 3 roots. And we sort of notice this lonely complex thing. And we know complex roots usually come from the quadratic formula, which means we usually get 2 of them. And so there is this fancy sounding theorem called the complex conjugate theorem. Which says that if you have a polynomial with real coefficients, which is what we normally have, right? So there's no i's in the original problem. If you have a complex number that's a 0, then its conjugate, which means you just switch the sign in front of the imaginary part, is a 0 also. And so sometimes the way we say this is that the non-real zeros, the ones with imaginary numbers, will always occur in pairs. So there will always be an even number of them. So 0 could be none of them, 2, 4, 6, and so forth. All right, so what does that mean? It means when we go back to this problem, I can right away add my third root. So 3 plus 4i is a root. And so what do I know? Well, I know that roots lead to factors, so we're trying to be careful about our language, right? So that there's a difference between the root and a factor. And so x equals 2 is a root, and so x minus 2 is a factor. 3 minus 4i is a root. And so x minus that, notice that inner set of parentheses, is a factor. And then x minus 3 plus 4i, again, inner set of parentheses there. Those are my 3 factors. Sometimes we know there might be a number out in front, and so we'll talk about that in a second. But for now, I'll just sort of put a placeholder there with the a value. So what do I need to do? Well, I need to figure out if there's an a value, and I know I'm not allowed to have complex numbers in my final answer, so I need to get rid of that. And there's a couple ways you can do it, but I'm just going to do a generic rectangle. And so I'm going to multiply those things out, and as I write it out, I'm going to get rid of the parentheses. So I'm going to have x minus 3 plus 4i for this one, and then x minus 3 minus 4i for this one. And so now I've got sort of a big generic rectangle, but it's not too hard to do. Just be careful with your negatives. And so x times x minus 3 times x minus 4i times x minus 3 times x plus 9, and then plus 12i, and then plus 4ix minus 12i, and minus 16i squared. And so, let me zoom in there a little bit. Now we're just going to clean this up. This is why we chose the conjugate, because some things are going to cancel out. So 4ix minus 4ix minus 12i plus 12i, so all those i's nicely going away. And of course this one doesn't cancel out with anything, but my I squared is negative 1. Negative 1 times negative 16 is positive 16. And so when I put this all together, I've got x squared minus 3x minus 3x minus 6x, 9 plus 16 is 25. And so these 2 factors up here actually multiply out to x squared minus 6x plus 25. The x minus 2 is here, and then that a is still there as sort of a mystery. Now, if you really want to, you could multiply these 2 things out. This is an x squared. We generally don't care about that, just as long as the i's are all gone. But you could get the full cubic if you wanted to get get rid of those parentheses with another generic rectangle. So the last piece of the puzzle now is, remember, I was also told that f of 1 equals negative 10. And so that means when I plug in 1 to this equation, I'm supposed to get negative 10. And so I'm replacing all the x's with 1. I guess that was an extra parenthesis there. And so I get a times negative 1. What's this? 26 minus 6 would be 20. And so I get negative 20a, and this is supposed to equal negative 10, and so a must be 1/2. And so now, after that whole process, I have a equals 1/2, I have my factor of x minus 2, and I have x squared minus 6x plus 25. And of course, this is a third degree polynomial, just as I was supposed to have, because if I multiplied this out, the highest power would be x to the third. That's it.